Okay, let's do page 2. Now it says find the intersection point. Well, this is a right side up parabola. And this is a line with a -2 slope. Notice how you need to be able to recognize things pretty quickly. And so the intersection will be when the height of this one, x squared minus 5x, equals the height of the other one. Now to find which the x's that make these equal, I'm going to solve this. And I'm going to solve it by getting it equal to 0 because it's a quadratic. So I'm going to add 2x, which makes it minus 3x. I'm going to subtract 10. And that does factor to x plus 2 and x minus 5. So x equal, so setting this equal to 0, I get x equals minus 2. Setting this equal to 0, I get x equal 5. So when x is 5, is this where they meet? And over here at -2 is where they meet again. But I want the points of intersection. So I can't plug -2 into this equation or any of these. I got to go back to the original equations. Now if I put it into f of -2 would be -2 squared minus 5 times -2, which is 4 minus plus 10, which is 14. And if I put it into g at -2, I get -2 times -2 plus 10. -2 times -2 is plus 4, plus 10 is 14. So that verifies that they do cross at -2, 14. Now, what about the other one? Well, if we put 5 into f, we get 5 squared minus 5 times 5. And that comes out to be 0. And put 5 in the other one, into g of 5. That would be -2 times 5, which is minus 10, plus 10 is 0. So they match up. So the points that they intersect at, it was -2, 14, and 5. They have both had a height of 0. So this point is 5, 0. So now for part B, we're supposed to decide when the F curve is underneath the G curve. Well, that would be for all x's between -2 and 5. From -2 to 5, F is under. At -2 or at 5, they're on top of each other, which is equal, which it says we can keep. So we can keep it when they're equal and all the numbers in between. And that's number 3. Now let's go to number 4. It says we have this, and let's see, that would be positive x squared, so it's a right side up parabola. And so I'm going to write it in order. X squared minus plus 6x plus 7. And if I want to find the maximum or minimum, well, it's a right side up, so it's going to have a minimum. And it'll happen at -b over 2a 2 times 1 is 2. And if I plug that into the equation, see that's negative 3, I'll have negative 3 squared plus 6 times negative 3 plus 7. So I get the minimum is, see, that would be 9 minus 18 plus 7. So that's minus 9 plus 7 is plus 2, or minus 2. That's the minimum value. That's how high it is at the vertex. Now, C says determine the vertex. Well, we figured out it's at minus 3 and has a height of negative 2. And B says, what's the line of symmetry? Well, that's the axis of symmetry, which is the opposite of B, negative 6 over negative 2 or negative 3. All right. So finally, when is it positive? Well, if this is a parabola, it goes like this, and the center line is at minus 2, and it's, yeah, and it says, when is it positive? Well, it'd be from the x-intercepts that way, it's positive, and this way, for these x's, it's positive. So what are the x-intercepts? So that calls for the quadratic. Oh, wait a minute, I'm supposed to do increasing and decreasing first. Increasing. Well, it'd be increasing from here on up, not including there. So there is at x equal minus 3. So I wouldn't include it, but on to infinity. And now I can find out where it's positive, which is each of these wings. For these x's and those x's, it's positive. So now I got to find the intercepts. So I'll use the quadratic formula. The opposite of b plus or minus the square root of b squared, which is 36, minus 4 times a, which is 1, times c, which is 7. So minus 4 times 1 times 7 is minus 28. And so that is equal to, just checking my answer here. I don't see, there it is. So that's going to be plus 8 in here. Oh, and this is all over 2 times a, which is 1. So I get negative 6 plus the square root of 8 over 2 and negative 6 minus the square root of 8 over 2 are the two x-intercepts. And this one's the smaller, and it actually reduces. I can put 3 into there, or 2 into there and get 3. 8 is 4 times 2, so I can take a 2 out and cancel it. So it's minus 3 minus the square root of 2. And minus 3 plus the square root of 2 are the two intercepts. I don't care if you reduce them for this particular problem. So you can either use these or these. But this is the smaller one. And we want to know when it's positive, so it's between the two roots. So it'd be positive, it can't be equal to 0. So we got open. And it would start at the smaller one, negative 6 minus the square root of 8 over 2 to the larger one, minus 6 plus the square root of 8 over 2. Okay.